Yeah, I don't know, technology sometimes doesn't work all that well. Okay, you'll probably notice that there are times when using the UDU notation is just too cumbersome and not all that necessary. Considering the following integrals, do them without using UDU. What? Oh, sorry. So the okay, do you want to do this one with UDU just as practice? So U equals 3x du over dx equals 3. And then you look at it and you go, Mr. F, there's no 3 there. So you move the 3 over to the other side. So you have du over 3 equals dx. So the antiderivative becomes e to the u times du over 3, which becomes 1/3 integral. This is so much fun. E to the u du. And then you go, the antiderivative of e to the u is e to the u plus c. And then you switch it back. And hopefully at some point along the way, somebody says, Mr. App, here's a fast way of doing this stuff. What is it? No. So if I ask you to do the antiderivative of e to the 7x dx, its antiderivative is? The antiderivative of e to the 1/2 x dx. No, yeah. E is e. It is a constant, but it's a special constant, right? Gotta be very careful when we're taking the antiderivatives of these things. Okay. So, do we need to do all that work when we see e to the kx? No, it gives us a formula. E to the kx dx is antiderivative is 1 over k e to the kx plus c. And I think if you flip over to the next page, you might see that one somewhere. Or next pages, I don't know, a couple of pages in. Is it just one page over? Almost hole punched out? Well, where is it? Oh, there it is. E to the, okay, it's e to the kx, 1 over k e to the kx plus c. Will you stop it? Good. The integral of sine u equals 5x. Du over dx equals 5. Du over 5 equals dx. And lo and behold, the same thing happens. Sine u times du over 5 becomes 1/5. And the antiderivative of sine is negative cos. And then you switch it back, and you get to a point you're like, Mr. This one isn't so bad either. Yeah. Oops. So can we fill in our formula on the next page? So if we fill it in for cos, it's negative 1 over k sine kx plus c. What's sine kx dx going to be then? Over k cos kx plus c. What's secant squared going to be? 1 over k tan kx plus c.
It's the opposite. There's no negative on the top and the negative on the other.
The antiderivative yeah, you're right. Yeah, sorry. Secant kx tan kx dx. The antiderivative of secant tan is secant. So it's going to be 1 over k secant kx plus c. Cosecant, cotan, that's going to be negative. Negative 1 over k cosecant kx plus c. And then cosecant squared is going to be cotan kx plus c. So you can skip a lot of steps. If it fits that pattern, bang, you write the answer down, you're happy, and you're done. Now, if you don't remember these patterns, then fine. You don't have to nobody said you have to memorize this box. Okay? I don't. I just go old school and use substitution, use the UDU notation to do it. So if we go back to the previous page, were there any there that we didn't do? So this one's going to be 1 over pi tan pi x plus c. Uh, 1 over 2/3 sine 2/3 x plus c. Now, do we write it as 1 over 2/3? No, we write it as 3/2 sine 2/3 x plus c. Oh, yeah, whatever. Sure. We'll zoom out a little bit. Are we good? Okay, so next page, we just wrote the rules down. So yesterday, or this morning, we looked at two integration formulas. The antiderivative of 1 over u is ln, absolute value of u, plus c. And the antiderivative of e to the u is u plus c. It's uic. I don't know. But the problem occurs, and you're going to hate me, the problem occurs when you try and do, well, no, you could do this one as well. Sorry, I'm loud. U equals x squared plus 1. Du equals, du over dx equals 2x, which means du equals 2x dx. So our antiderivative formula becomes much cleaner. So it becomes ln u plus c. Yeah? Or no? But it's all about the choice for you. If you don't choose u properly, you are screwed. Well, because it's not getting cleaner. Yeah. It's not turning into a pattern that you recognize. So, next one, u equals x squared plus 1 du equals 2x dx. So our antiderivative becomes 1 over u squared du. And you don't use ln here because it's a power of 2 in the denominator. Add 1 to negative 2, you get negative 1. Divide by negative result. Add c to it, and you're happy. So it becomes negative 1 over yeah. Okay, what are you going to let u be here? Mr. These are boring. Oh, I know why we're doing this. So u equals x squared plus 1 du over dx equals 2x. I see an x, but I don't see a 2. So the antiderivative becomes 1 over the square root of u times du over 2. So you can write it as right? Take the half out front, change the square root into the 1/2 power, flip it up, make it a negative exponent. Add 1 to negative 1/2, you get positive 1/2. So it's u to the positive 1/2 divided by the result, positive 1/2 plus c. No, he went skiing. Well, apparently. Yeah? So you get the square root of whatever that stuff in the brackets was. Makes it cooler with laser sword fighting sounds. Okay, now you look. Okay, sorry. It's a stupid commercial, okay? I'm a product of marketing.
Have you seen that?
No, I haven't seen it. Really? And they put it all in? And the laser sword's in? Nice. A lot of patience, I think. They did? So number 4 doesn't fit any of the patterns. And I'm like, why are we doing this? Oh, and I went, oh yeah, right. So if you let u equal x squared plus 1, you look at it and go, oh, no, don't write it down. It doesn't work. So you have to dig into your derivative formulas to look for a function that has a derivative of 1 over 1. I'm going to write it in the way that we wrote it in our notes. No. Close. No. Arctan. Archy, siny, tenny thingy. The antiderivative of the derivative of arctan. Now, depending on the textbook you use, you'll see it like that as well. No. No. You just have to recognize the pattern. So, oh no, what's going on? Yes, you guessed it. This is the last of the formulas that you must know. Let's remember how we differentiated the inverse tangent. What? Till chapter 7. application of integration. So I'll talk about work, and I'll talk about, or network, and things like that. Okay, so the derivative of arctan is 1 over 1 plus x squared. The derivative of arctan u is 1 over 1 plus u squared times u prime. So what's the arctan of 3x? The derivative of arctan of 3x? Times 3. Now, probably going to hide it a little bit and write it as 3 over 1 plus 9x squared. Okay, what about arctan of e? And the derivative of e to the x, e to the x. We're probably going to hide it a little bit. We might write it as can't really hide this one that much. Nothing. Suppose 1 minus cos squared x would be a beautiful thing. Be sine squared, yeah, be tan. Okay, so what would be the corresponding integration formula? So the antiderivative of 1 over 1 plus x squared is arctan x. The antiderivative of 1 over 1 plus u squared is arctan u. Do you want tan to the minus 1 or arctan? So, ready? Let's use them. Let's use them. Psych. Okay. Turn the page. So take the 5 out front. Integral 1 over x squared plus 1 dx. And then if you don't like it as x squared plus 1 because it doesn't match the pattern, you can flip it around. Most kids just jump from here to here. Would you agree? So that it just becomes 5 arctan x. Yes? Yep. As long as it's common throughout, you can factor it out and take it out front and get it out of the way. It's a good strategy. I didn't use it very often in university. Okay, next one. You look at it and go, hey, Mr. App, what if I did this? You picking up what I'm laying down? U equals 2x. du over dx equals 2. Hey, Mr. App, I don't see a 2 there. You're right, because there isn't one. Change it around. All right, I'll do that. And you get you take that half out front. And then arctan it. And then change it back and you're happy. Yeah, it has to match that shape of arctan. 1 over 1 plus something squared. It has to match that shape. Okay. I think we've already done this one. Put back in your notes. Yeah. Anyways, I'll set it up so it looks like something that we've already talked about in our notes. So that's what you need to see. You need to see 1 plus something squared. Okay, you have to see that. So you'll let u equal e to the x, du over dx equals e to the x. So the antiderivative becomes it's just arctan e to the x. It's because it becomes 1 over 1 plus u squared du. Should I zoom out so you can see what I'm talking about? Get a little highlighter going on. This is this one, and this is, yeah, no, yeah, so then it becomes arctan u plus c, so it becomes arctan e to the x plus c. 11. This one doesn't fit. It's going to cost you $50. Are you doing this for Mr. Roll? Okay, thank you. Ooh, hurry up. Let's go. Number 11. Why doesn't 11 fit? Why? Because yeah, I guess that's it's a crappy reason, but what if you do this? Tell me the derivative of that. E to the 2x times 2. Okay, Mr. F, I see the e to the 2x. I don't see the 2, so you can write it as du over 2 equals e to the x, e to the 2x dx. So what I'm saying is this comes out, and du over 2 comes in, and this comes out, and u comes in. So don't always assume that it's arctan. Okay? It's 1/2 ln u plus c. So it's ln e to the 2x. Oh yeah, sorry, you're right. Can I? So you just got to be careful. Sometimes when it's squared in the denominator, it doesn't automatically make it arctan. You need to see 1 plus something squared. You think arctan. If it works, great. If it doesn't, then it's got to be ln probably. What are you going to let u equal in number 12? Sin x. If you let u equal 1 plus sine squared, it doesn't work out very nice. U equals sin x. So du equals cos x dx. So you smile and go, hey, cool, there it is, cos x dx. There it is, cos x dx. So you get the antiderivative of 1 over 1 plus u squared du. Beautiful things happen. It's arctan of sine x. Plus c. Newton. Leibniz. Both of them. Independently. No, they didn't work together. No, just... No. U equals 1 plus sine squared x. So du over dx equals 2 sine x times the derivative of the inside cos x. I think this is the last one I want to do. Oh, I'll show you why. Okay, so I'll do it this way and then I'll pretend that I was trying to use arctan. What am I doing? Okay, you got to remember that it means this. Right? So when you do the derivative of the outside, it becomes 2 sine x to the 1 times the derivative of the inside cos x. Okay? And then you might have to get a little math 12 on it. Go, hey, that's sine 2x. So this comes out, du comes in, and then 1 plus sine squared comes out, u comes in. Let's pretend that I don't have a clue. I'll do this as if I was trying to force arctan on it. How's that sound? So the starting question is, so you go, okay, we'll let u equal sine x. So du over dx equals cos x. So du is equal to cos x dx. And then you go, where's the cos x to dx? So you do this. You go 102 sine x cos x over 1 plus sine squared x dx. So that can become, well, you get a u here and you get a u squared here. Times du, and then you look at it and you go, do I know any rule that allows me to deal with that? And then you go, okay, oh yeah, you guys' brain hurts yet? Now I'll do substitution of substitution. I'll let v equal 1 plus u squared. So dv over du equals 2u. So the antiderivative becomes the antiderivative of 1 over v dv, so that becomes ln v plus c, and then you take out the v and you put in what v is. V is ln 1 plus u squared plus c, and then you take out the u squared and you put in what u is. U is sine x. Ln 1 plus I still didn't use arctan. I tried to, and it still wouldn't let me do it. Because there's no way arctan has got to be 1 over as I erase. ln's got to be 1 over. That u up there is screwing it up. Okay? It's got to be 1 over, not 7 over. Well, 7 we can take it out front. But it can't be u over. Yeah, I know, substitution of substitution. Scary? Yeah, I don't think you'd ever want to use that strategy. Did it make sense? I went really quick there, but use substitution, they use substitution again, and they use back work. Okay. There it is. That's where we'll stop for today. So if you are one of those kidlings that have got everything done, you can do those supplement questions. I wouldn't do the arc sign ones yet. We'll leave those for tomorrow. Thursday. So Thursday we will do arc. What's tomorrow? Tomorrow's your chapter 4 test. So Thursday we're going to do arc sign, and we will do what's left? Differential equations and slope fields. Oh my. Well, no, probably different. Tomorrow, no, God, no. I want to be done, Spencer. Aw, Puddin', that's too bad. No, it's not even close. No,